Hello friends, this video on P block elements part 11 is brought to you by examfear.com. No more fear from exam. Now we'll talk about the reactions or the chemical properties of the nitrogen. Please note, I'll not talk only about nitrogen, we'll talk about the whole nitrogen family. We'll talk about the reactions of nitrogen family elements with hydrogen, with oxygen and with halogens. We'll talk about these three things. And we'll also talk about the reaction of nitrogen family elements with other metals. So let's start with the reaction of nitrogen family elements or the group 15 elements with hydrogen. See, all the elements of group 15, they form hydrides. Of typical form EH3. This is the form they form, where E can be any of the element of group 15, right? For example, I'll start with N, NH3 is ammonia, then P, it forms PH3, then arsenic, ASH3, right? Then my antimony, it forms SBH3, and then bismuth, it forms BiH3 also. They all these elements form hydrides of EH3 form. Now let's talk about the stability of these hydrides. See, the stability of this hydrides decreases down the group. NH3 is thermally stable. NH3 is stable. Right? If I talk about my SBH3 and BiH3, they are unstable. So if you see, going down the group, the stability of the hydrides decrease. Correct? Now the question is why? If you see the trend, stability trend, NH3 is more stable than my PH3 and then my ASH3 and then my SBH3 antimony and then my BH3. Why? See, if you talk about the electronegativity, this nitrogen is more electronegative. Right? And thus it is more stable. If we talk about Bi, this is less electronegative. And thus it is less stable. So if you see the nitrogen, the electronegativity is 3. Right? For hydrogen, it is 2.1. Correct. So if we compare these two, there is a difference in electronegativity. We talk about NH3 here. Right? Since there is a difference in electronegativity and nitrogen attracts these electrons towards itself, so nitrogen will develop slightly negative charge, and hydrogen will develop slightly positive charge. Because of these charge, you can have H bonding now. But if you talk about BiH3, so the bismuth electronegativity is 1.9 and hydrogen is again 2.1. The difference in electronegativity is not that much. In nitrogen it was 3 and it was 2.1. The difference was more, so you have H bond here. You have no H bond here. With that factor also, this is more stable. Right? This is more stable. Correct? More electronegativity implies more H bond, implies more stability. Right? Since it is more stability, that means it has less reducing power. Why? Because it is more stable. It won't reduce. Correct? So that's all we have for this. If you talk about the basic nature, it is more basic here. This is less basic here. Similarly, it has more reducing power because it is less stable. It has more reducing power. Correct? So this is the trend we have. As I told, my ammonia is strongly basic. It forms salt with weak basic as well as strong acid. Because it is more basic, right? It will form salt with my weak and as well as strong acid. So it will form salt with my weak as well as strong acid, because the basic forms salt with acid, right? So it will form salt. Since it is more basic, it will form salt also with weak or strong acid. pH3, if you see phosphine, is weaker base as compared to ammonia. So it will form salt with strong acid only. Correct? See, ammonia is a weaker base, is a very weak base, or it's a very strong base. It will form salt with weak and strong acid. My pH3 phosphine is a weaker base as compared to ammonia, so it will form salt only with strong acid. Correct? If we talk about AsH3, SbH3, BaH3, they don't show any basic character. These guys, no basic character. I can say this is no basic. Also, why? Because they becomes more metallic, so they don't show any basic character. Okay. If we talk about the solubility of these hydrides, this ammonia is highly soluble in water because of hydrogen bond. Because I have seen that due to the difference in electronegativity, ammonia forms hydrogen bond. Since it forms hydrogen bond, it is soluble in water. These are all insoluble in water. Only ammonia is water soluble. This is the only water soluble compound. So if you talk about the reducing nature of these hydrides, we have seen that ammonia has very less reducing power. So except ammonia, other hydrides of this group, they act as reducing agent. They act as good reducing agent actually. So they react with metal ions, for example copper ions, silver ions, to form phosphides, arsenides, antimonides, etc. These are having good reducing power. These ammonia also act as a Lewis base. I told they are more basic. Why? See, ammonia, if you see, this ammonia has lone pair of electron. And if you talk about this BF3, let's suppose this ammonia reacts with BF3, these electrons it can give it to boron and it will form a bond. Thus, since it is giving electrons to boron, it acts as a Lewis base, yeah. If we talk about the boiling point of ammonia, that is higher than that of phosphine. If you see the boiling point, this is higher, the boiling point decreased. Why this is higher? If you compare these two, because of the hydrogen bond. Correct? Again, if you see nitrogen and pH3, let's compare this nitrogen and pH3 here. NH3 is here compared, and pH3, let's compare here. pH3. Phosphorus has electronegativity of 2.1, hydrogen also 2.1. So if you see, phosphorus won't be attracting electrons of hydrogen. So the electronegativity is almost same, correct? So there will not be any hydrogen bond. So if you compare nitrogen and NH3 and pH3, ammonia and phosphine, ammonia has higher boiling point because of hydrogen bond. Okay. Another important hydrides of nitrogen is N2H4. It is called hydrazine. It is prepared by oxidizing ammonia with sodium hypochlorite in a dilute aqueous solution. you want, I can write the reaction for this. NH3 plus NOCl give here's the place. Let me write here. NH3 plus NOCl gives N2H4 plus NaCl and water. This is my hydrazine. Okay, so this is all about reaction with hydrogens. All of these forms EH3 hydride, ammonia, PS, phosphine, ASS3, SBS3, BAS3. If we talk about the stability, NH3 is more stable, BIS3 is less stable because of the electronegativity factor we discussed. Right? If we talk about the solubility, NH3 is the only one which is water soluble because of hydrogen bond, other are not water soluble. NH3 is not having reducing power, but other elements, other hydrides are good reducing agents, right? And ammonia is basic, NH3, others are not that basic. In fact, they don't show any. PS3 also shows a little bit of basic character, but apart from phosphine and ammonia, other elements, other hydrides, they don't show any basic character. Ammonia shows more basic character than PS3, it's more basic, and the special thing about the ammonia is that it has hydrogen bond. With that, its melting point, boiling point, everything is more. If we talk about the melting point also, the melting point is more. Okay. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.